Get ready for one of the most insane engineering stories ever told. This is the story of the rocket that learned to fly home. Okay, let's just jump right in with a wild question. Can you imagine throwing away a jumbo jet after just one flight? I mean, flying it once and then just ditching it in the ocean? It's completely insane, right? Well, believe it or not, for over 60 years, that is exactly what we did with rockets. Every single time we launched something, anything, into space, we were throwing away these absolute masterpieces of engineering. I mean, we were literally throwing away skyscrapers. That's what these things are: colossal, unbelievably complex machines, and we were treating them like they were disposable, just one and done. And the cost? Well, it was astronomical. And when I say astronomical, I mean it. The sheer scale of this waste is just staggering. Just look at the Space Shuttle. On average, a single mission cost around $450 million. That's nearly $500 million gone with every single launch. It's no wonder that getting to space was so incredibly, prohibitively expensive. So, a few brilliant and maybe a little crazy engineers started asking this really simple question. What if we didn't have to throw them away? You know, what if we could actually teach a machine the size of a building how to fly back from the edge of space and land itself perfectly? But here's the crazy part. Getting the rocket home is actually way harder than getting it to space in the first place. It is an absolutely perilous journey. A high-speed, high-stakes dance with physics. Okay, so once the rocket drops off its payload, it performs this incredible landing ballet. First, stage separation. It attaches. Then, the boost back burn. It literally flips itself around 180 degrees and fires its engines to completely reverse course and head home. Then comes the reentry burn, firing those engines again to hit the brakes before slamming into the atmosphere. After that, it's all about steering through the air using these tiny wings, all the way down. And for the grand finale, the landing burn. A final engine fire for a perfect, soft touchdown. It's like a 5-act play, and every single step has to be flawless. And check this out. This is one of the coolest parts, how it steers. These things are called grid fins. See how sleek they are for the ascent? Tucked right in. But on the way back down, they pop out like this. They act like rudders, but for the sky. This is what lets the rocket steer itself with insane precision, even while it's falling at thousands of miles per hour. Okay, but wait, this brings up a pretty huge question, right? How does a giant metal tube survive falling from the sky at hypersonic speeds without just, burning up into a million pieces? This right here, this is the real climax of the journey. Taming that fiery fall. It's all about surviving what is maybe the most violent environment any machine will ever face: atmospheric reentry. So picture this. The rocket is slamming back into the atmosphere, going thousands of miles an hour. The energy is just terrifying. It gets completely wrapped in this sheath of glowing hot plasma. It literally becomes a man-made shooting star. And here's a totally mind-blowing fact for you. That insane heat, it's not from friction. That's what everyone thinks, right? Nope, it's actually from atmospheric compression. The rocket is moving so ridiculously fast that the air molecules in front of it just can't get out of the way. So instead, the rocket violently squishes them together, compressing them so hard they literally ignite into a superheated plasma. And we are talking about some serious heat here. Over 1,500 degrees Celsius on the rocket's leading edges. To put that in perspective, that is hotter than volcanic lava. The level of engineering you need to build something that can survive that, it's just on a completely different plane. So, okay, how on earth do you build something to survive that kind of inferno? Well, it turns out there are a few different ways to do it. Think of them as different families of spacecraft, sort of like shapeshifters, each with its own survival strategy. It really boils down to two main ideas. You can be a glider, using wings for a long, controlled, almost gentle descent, or you can be a dropper, and just use a blunt, tough shape to pretty much cannonball your way through the atmosphere. It's brutal, but hey, it's simple, and it works. The most famous glider, of course, has to be the Space Shuttle. I mean, it was an absolutely elegant solution, right? It landed on a runway just like an airplane. But the problem was, those big, complex wings also made it super fragile and unbelievably expensive to get ready for the next flight. Then you've got these really weird, kind of futuristic-looking things called lifting bodies. They're a strange hybrid. They don't have wings, but their whole shape is designed to generate lift. It's this bizarre, wingless wonder that gives you way more control than a simple capsule, but without the headache of having big, fragile wings. And finally, you have the droppers, the tough guys, the blunt body capsules. Think Apollo, think Dragon capsules. Their design is genius in its simplicity. That rounded bottom creates this powerful shock wave in front of it, which physically pushes that superheated plasma away from the heat shield. Sure, it's a rough ride, but it's simple, it's tough, and ultimately, this is the philosophy that cracked the code for reusable rockets. But here's the thing. All of that, landing the first stage, that was just step one. The real prize, the holy grail of all this, is full reusability. Yeah, landing the first stage is incredible, but that's just half the rocket. The second stage, that's the part that actually goes all the way to orbit. It's traveling way higher and way, way faster. Getting that part back? Well, that's the final boss of rocket engineering. And right now, a whole new generation of engineers is taking on that exact problem. Companies like Stoke Space are trying a totally new approach. Their CEO, Andy Lopsa, sums up their philosophy perfectly. You have to design, build, test, iterate as fast as you can possibly do it. Basically, move fast and build things. And their idea is, well, it's pretty out there. They're building a fully reusable second stage, which is already a huge deal. But get this, their heat shield is also the rocket engine. Yeah, you heard that right. It's a shield that actively cools itself during that fiery reentry, and then it fires up to land the rocket. It is a total game changer, all designed for one thing, turning rockets around fast, just like airplanes. So why does any of this matter? What's the big deal? Well, because mastering reusability isn't just about saving a bunch of money. It's about fundamentally changing our entire relationship with space. It's about unlocking a brand new space age. When you look at a machine like this, you're not just looking at a rocket anymore. You're looking at the start of a future where getting to space is cheap, common, and totally reliable. This is the key that could unlock cities on Mars, giant factories in orbit, a future that, until now, we've really only dreamed about. This whole journey just proves one thing, that with enough brilliant ideas and maybe a little bit of craziness, we can solve problems that seem completely impossible. Which leaves us with just one final question to think about. We taught a skyscraper to fly home from the edge of space. So what impossible dream should we chase next?